right, welcome to day 2 of section 7.4, adding and subtracting radical expressions. So yesterday we ended on the fact that in order to add and subtract rational expressions, you had to have a common denominator. And so I gave you denominator, you found the least common denominator, and then we were able to create common denominators and add across. And so we're just going to extend on that idea. Okay, so I've got 4 examples here. The first one is to find the sum. Okay, now here, the reason why today is different than yesterday is that today we have to factor before we can find the LCD. Okay, so that denominator there is 3 times x times x. Okay, so go ahead, the restriction there, x can't be 0, right? And then this here, this actually factors, we can take out a GCF of 3. So if we take out a GCF of 3, we end up with 3 times, and then we end up with a 3x squared minus 4. Okay? So that's where we are in life here. Those are the factors. We cannot factor that anymore. If it were x squared minus 4, you could factor that. But 3x squared minus 4, that does not factor. So we just leave it just like that. Okay? All right. So that means that the LCD here, okay, is also this restriction here is x can't be plus or minus the square root of 4/3. Don't worry about it. Okay, you're not going to get a restriction like that. Normally you would just set them equal to 0. But anywho's, moving on. The least common denominator here is, well, okay, so we got to take everything from the first and then whatever from the second that we don't already have. So we have the 3, but we do not have the 3x squared minus 4. So the LCD here is 3x squared times 3x squared minus 4. Okay? All right, so then we go over here, and we've got 1 divided by 3x squared plus x over, and then I'm going to write this as 3 times 3x squared minus 4, just so it's in factored form. And now we have to think, okay, well, we need this denominator to look like this one. So what are we missing? Well, we're missing the 3x squared minus 4. So we multiply it by 3x squared minus 4 and a 3x squared minus 4. And then this one has the 3 and the 3x minus 4, but it's missing an x squared on the top and on the bottom. Okay? And now we multiply. 3x squared minus 4 times 1, well, that's just 3x squared minus 4. And now our denominator is our LCD of 3x squared times 3x squared minus 4 plus x times x squared is x cubed divided by, and then our LCD of 3x squared times 3x squared minus 4. And now that we have common denominators, we can just add across. I'm going to start with my first term of x cubed first. Then I've got a plus 3x squared. Then I've got a minus 4 divided by 3x squared times 3x squared minus 4. Okay? And that top doesn't factor, so if it could factor, you should, but this one does not, so you don't have to factor. Okay? Stellar. Example 7. Same thing here. Find the sum. So the first thing we need to do is factor that. Well, 9x squared is 3 times x times x. So then we have a restriction that x can't be 0 because that's a denominator. And then this one here, we can factor out a 3 and an x. And then left over, we would have an x plus 1. So our LCD is everything from the first. So 3 times x, and then whatever's missing from the second. Okay? So your LCD here would be 9x squared, x plus 1. Okay? So now let's make that denominator happen. So we come back over here. We start with 7 over 9x squared. Okay? So we've got the 9x squared part, but now we need the x plus 1. So we multiply by x plus 1 in the numerator and denominator, plus Okay, and then we've got 3x squared plus 3x. So that actually factors there. So that's good for us to know. So we're missing, we have a 3, we need to get, hold on, let me rewrite this, x, and then 3x squared plus 3x. So, well, here. I would highly encourage you to write the factored form of 3x times x plus 1. So we have a 3, we need to get to 9, so that means we need a 3. We need to get to x squared. We only have one of them, so you need an x, but we've got the x plus 1. So that means we multiply those two. And now we just clean it up. So we've got 7 times x plus 1, which gives us 7x plus 7, divided by our LCD of 9x squared times x plus 1, plus, and then x times 3x, that gives us a 3x squared, divided by, and then the bottom becomes 9x squared times x plus 1, which equals, if we write it in standard form, now we just add across 3x squared plus 7x plus 7 divided by the LCD of 9x squared times x plus 1. And you can stop there. There's nothing that you can do. Okay? We do need to find the restriction on this denominator. So we already have here that x can't be 0, but also x cannot be -1 because of that denominator there. Okay, so you can either find restrictions in the beginning or end. It doesn't really matter to me. Alrighty? All right, 2 more here. Let's find the sum here. Okay, so the first thing we have to do is factor. So this here, that factors to x minus 4, x plus 3. So the restrictions are x can't be 4, x can't be 3. Okay? And then that one, well, you can take out a GCF of 12, and then you're left with x minus 4. So we already have that restriction of x can't be 4. So that means that the least common denominator is everything from the first, which is x minus 4 times x plus 3, and then whatever we're missing from the second, which is a 12. Okay? So then we go back and we've got, okay, x divided by, that denominator is x minus 4 times x plus 3, and we're missing the 12. So we're going to multiply the top and the bottom by a 12. Plus, then we've got 5 over, that factors to 12x minus 4, so we're missing the x plus 3 and x plus 3. Okay? So now we just clean it up. X times 12, well, that's 12x over 12 x minus 4x plus 3. Okay? Plus, and then 5 times x is 5x. 5 times 3 is a plus 15, divided by 12 times x minus 4 times x plus 3. Okay? And then we just clean it up. Now that we have denominators, we just combine like terms. So 12x plus 5x, that's 17x, and then we've got a plus 15, divided by 12 times x minus 4 times x minus 3. Okay? Beautiful. All right, last one here. Here we go. Find the difference this time, which is just the same thing as addition, just with a negative. So factor the denominators first. That has a GCF of 2, so that factors to 2 times x minus 1. This one here factors to x minus 3, x minus 1. So the LCD here is 2, x minus 1, x minus 3. The restrictions are x cannot be 1 and x cannot be 3. Okay? Beautiful. So now we go and we have, okay, x plus 2 over 2, x minus 1. So we need the x minus 3. We need the x minus 3. Okay? And then we've got minus negative 2x minus 1 over, this is x minus 3x minus 1, so we're missing the 2. Okay? Now this gets interesting because this is a binomial times a binomial, which means you have to FOIL. So we've got x and x, which is x squared, x and a 3, which is a negative 3x, a 2 and an x, which gives us a plus 2x, a 2 and a negative 3, which gives us a negative 6. And we've got that denominator of 2 times x minus 1 times x minus 3. And then we've got minus, okay, now let's think of that as a quantity, negative 2x times 2, which is negative 4x, and a negative 1 times a 2, which is a negative 2, over 2 times x minus 3 times x minus 1. And now we combine, but remember, we're subtracting, so be careful. We don't have any more x squared, so that just stays x squared. I've got negative 3x plus 2x, which is a negative 1x, minus a negative 4x. So I've got negative 1x plus 4x, which gives us a plus 3x. Okay? And then I've got negative 6 minus negative 2, which is negative 6 plus 2, which is minus 4, over 2 times x minus 1 times x minus 3. And normally we would be done, except for the fact, I've always told you if it can factor, you should, because watch. The top of this factors 2, x plus 4, x minus 1, divided by 2 times x minus 1, x minus 3. And that's important because then you can simplify and you're left with your final answer of x plus 4 divided by 2 times x minus 3. It's not common that that happens, but it does happen. Okay? So, you can come and pick up your homework. Wait till I'm done teaching to ask me any questions, but hopefully if you need to rewind or go ask something, you can. Okay?